All right, guys. Can anyone tell me if they can hear my mic? I just want to make sure the audio is working as well. Excellent connection. All right. Okay, thank you very much. I can start answering questions if people have any specific ones. I have some extra textbooks if there's things you guys want to work on. If there's not any other questions, but I can help you. So, any questions? All right. Sure. All right. So page 407, number 4. Okay. All right, so I'll start with Isla's question 407. That's from the Nelson book, I believe. 407, number 4. Okay, so for this one here, you're given the following. You've got the cos of theta is negative 4/5, and you know that theta is bounded between pi over 2 and pi. So draw your little unit circle here. I'm between pi over 2 and pi. So I know I'm in this quadrant here. And they told us that the cos, this is adjacent, hypotenuse. This must be a 3, 4, 5 triangle. Right, if you're working on this, this would be a 3, 4, 5 triangle. I'm not sure if there's a lag here. Isla, can you see the diagram and everything already? Because I've already drawn this unit circle and everything. Oh, you can. There it is. 3, 4, 5. Okay, so this is a 3, 4, 5 triangle. In the question Isla's asking here, they want to find sine of 2 theta, the cos of 2 theta, and the tan of 2 theta. Oh no, I was copying number 7. Oh, this is 7. Oh, you know what? I've already got 7 here. I'll do 7, then I'll do 4. So you get a bonus one. All right. Let me do 7, and then I'll take up 4 that Isla wanted. Okay, so for 7 here, this was a setup for 7, so I already got it all drawn here. The idea here is once you get yourself in your unit circle, everything's drawn here. You know the sine of theta is your opposite over hypotenuse. So in this case here, it's going to be 3 over 5. Always make sure you check to see whether in that quadrant you're positive or negative. Sine is positive in that quadrant, so I leave it as 3/5. Yeah, I'll do 4 as well. So I'll leave it as 3/5 here, positive 3/5. So for sine 2 theta, that's going to be 2 sine theta cos theta, which is 2 times your sine of theta is 3/5, and your cos of theta, they gave us in the question, is negative 4/5. So this ends up becoming equal to, that'll be 6 minus, that'll be minus 24 over 25. So if anyone was looking for 7, the sine is going to be minus 24 over 25. For the cos here, you can use any one of the formulas here. You can do 2 cos squared theta minus 1. It doesn't matter. But my cos here is negative 4/5 squared minus 1, in which case I get 2 times 16 over 25 minus 1. This one. Double that. So that's 32 minus 25. And I'm getting 7 over 25. So I've got the cos of 2 theta is 7 over 25, and the sine of 2 theta for number 7, although no one asked it, is minus 24 over 25. So therefore, if I do the tan is just the division of the two. Divide these two out, and you get negative 24 over 7. Okay, so there's number 7. Oh, is my screen blocked again? Let me make sure. Okay, so there's the answer for 7. Isla actually wanted 4. Yeah, sure, Tareem, I can go through that. Oh, okay. Do you want me to go through it? I can go through it if you want. Okay, Mahir and Tareem, I can definitely take those up. Donish, the 3-4-5 triangle, how I got that was, it's a good question you asked because you missed a bunch of that class. So what happened here is I knew this was 4, I knew this was 5. To find this x here, I did Pythagorean theorem. And when you do Pythagorean theorem here, you end up getting, when you solve this, you end up getting x is 3, right? Okay, thanks. But you know what, Donish, we did it so much that it just becomes a special triangle that we write down. That's where I got that from, is I had to do the Pythagorean theorem. Okay. Yes. Yep, you got it, Donish. Exactly. Very good. Okay, we'll get to Tareem's question here and Mahir's question. What is this one? Oh, okay. So Tareem, for this question here, they give you that you have sine of 65 is equal to x and cos of 65 is equal to y. And they want you to express the sine of 25, cos 25, tan 25 in terms of these values here. So the idea here is, notice if I add these two together, you get 90, right? 65 and 25 is 90. So that's kind of a hint that I should look at these correlated angles. So what is the sine of, since they gave it in degrees, we'll use degrees. So what's the sine of 90 degrees minus x? Like, what is that equal to? You can go ahead and do your compound angle formula. If I do my compound angle formula here, I end up getting the following, right? Using my compound angle formula. And the sine of 90 is 1. This becomes cos x times sine x. Cos of 90 is 0, so that goes away. This ends up being the cos of x. Right, so therefore, I could do the cos of 25 degrees is going to equal the sine of 90 degrees minus 25 degrees, right, which is exactly equal to the sine of 65 degrees, which is exactly equal to x. Are you able to follow that, Tareem? So the sine of 90 minus x we showed was cos of x. So therefore, I let x be 25, and I end up showing the cos of 25 is equal to the sine of 90 minus 25, but that's sine 65 as we know. 90 minus 25 is 65, and that's your x value. Yeah, for sure. So this example here, they wanted the sine of 25 degrees. So what I did was I said, well, okay, 65 and 25 is 90. So I was curious if there's a compound angle formula that I can use. So we did this numerous times. So I looked at, like, because it added up to 90, I looked at 90 minus x. And I just took the sine of it. I could have tried the cos as well. If I do the sine of 90 minus x, I get sine 90 cos x minus sine x cos 90. It ends up simplifying to become cos of x. So that means the sine of 90 minus x is cos of x. Well, one of the three I wanted was cos of x, cos of 25. So what I did here, Salem, since you're asking, is I let x be 25 degrees, and I subbed it in here. But then therefore that's got to equal the sine of 90 minus 25, which is equal to sine 65, which they told us is x. So cos of 25 is x. Right, we could do the same thing with the other one too. I could take a look here, and I could say, what's the cos of 90 degrees minus x? That's going to be cos 90 cos x plus sine of 90 sine of x. And the cos of 90 degrees is 0, so that'll completely go away. The sine of 90 degrees is 1, so this simplifies to become the sine of x. Right, so now I've got this relationship here. See? So now I could do the same thing here. I could say, okay, well, I'm going to let x equal 25 degrees. Therefore, the sine of 25 degrees, which is something else we want, has to equal the cos of 90 minus 25, which is cos of 65 degrees. And that's equal to y. So now sine 25 equals y. Sure, Tareem. Okay, let me know, like, I can explain it to you, Tareem. You just have to kind of text in the text box so I can kind of see where we're at. Because, like I said, there's a lag on my computer, so I don't know, like, what part you're seeing versus myself. And Mahir, I have not forgotten about your question. Okay, so if you just kind of focus your attention here, I now know the following. I know the sine of 90 minus x is equal to the cos of x. Right? This is what we've now shown. I have this. Oh, sorry, Tareem's got it. Okay, Yusria says I'm confused by. So we have this relationship here, Yusria. So what I did was I just let x equal 25. If you let x equal 25 here, you get the cos of 25 is equal to the sine of 90 minus 25, which is 65, which they told me in the question is x. So that's what they wanted in the question. They wanted the cos of 65 in terms of x and y. So I've got that done. And then I did the same thing for cos of 90 minus x. I showed it was equal to sine of x. And then I did that exact same sort of trick again, and I got the sine of 25 is y. So therefore the tan of 25 degrees, as you know, is sine 25 over cos 25 is exactly equal to x over y. And then we're done with this question, x over y. Oh, why did I choose 25? Because the question asked for 25 right here. The original question is asking me to find the sine of 25, cos of 25, and tan of 25. So that's how I knew. The question itself was asking for the sine of 25. Mahir, are you still there? I can take up your question here. 112.5. Does anyone want to practice exact values? All right, so I don't know if Mahir's still here, but I'll go through the question because it's a good one anyway. Excuse me. He was asking for the sine of 112.5 degrees. Again, if you take 112.5, the first clue is if you double 112.5, you get 225. Right, so if I want to find the exact value of 112.5, it's if you double that, you get 225. So I guess the problem maybe Mahir is having is I would use this formula. Like, you know, the cos of 2 theta is 1 minus 2 sine squared theta. So therefore, if I let theta be the 112.5, you know the cos of 225 is 1 minus 2 sine squared of 112.5, right? That would be the way to go with this one here. So cos of 225, again, you can use your calculators if you like. If you're looking to do it using the unit circle, for sure, Jack, if you're looking to do it using the unit circle, 225 is exactly 45 degrees after 180, so we're like right here. So your coordinates here are negative root 2 over 2 and negative root 2 over 2. So your cos is going to be negative root 2. Oops. Your cos will be negative root 2 over 2 is 1 minus 2 sine squared of 112.5. And then you can go ahead and solve this. So this will be 2 sine squared 112 and a half, 1 plus root 2 over 2. So then, get a common denominator here. Right, divide across. And let me know here if you're not following or need any explanation here. Over 4. Then I can take my square root. Sure. For sure, Dream. So here in this case here, I did the formula isolated for sine of 112 and a half. You get this plus or minus when you take your square root of something because you have those two options, right? Both would satisfy this equation. But you notice here 112.5 is in this quadrant here, and sine has to be positive. So therefore, our answer is 112.5. Take the positive square root. So it's going to be 2 plus root 2 over 4. They'll probably simplify it to become this. And that's your answer for this one. Sure, let me jot some of these down. Page 501, number 12, 469, number 54. No problem here. 463, numbers 39 and 40. Okay, we can start with those. So 501. Okay, so page 501, number 12, I can do that. Okay, page 501, number 12 here. So Jack, for this one here, they want you to express cosecant of x in terms of cotangent x. The cosecant of x is 1 over the sine of x. Okay, we got 54, 51, and 52. I'll add that, Alexa. So cosecant of x, 1 over sine of x. The cotangent of x is cos of x over sine of x. So Jack, the observation with this one is if you take cotangent squared of x and you subtract 1, that's going to be cos squared of x over sine squared of x minus 1, which is cos squared of x minus sine squared of x. No. Well, I don't know if I want to say just yet, but I don't think so. I kind of asked it because I thought it'd be good practice to go through. But Actually, you know what? Here, let's just to show you, Jack, to show you, let's make this a plus. Make this a plus. This ends up turning into 1 over sine squared of x, which is cosecant squared of x. So the relationship here is cotangent squared of x plus 1 is cosecant squared of x. We'll get to this more so when we get to our trig identities, but as Tareem had asked, I'm not going to be putting these on the test, but this would be the identity that you can use to make this answer work for you for 12. I just wanted you guys to get practice with, I won't use those terms, like it's nothing really special about cosecant, it's just 1 over sine of x. And this is just cos x over sine of x, but we'll reserve like that notation for another test or exam. $185, eh? Okay, I'll get to all these questions. Jack, does that help you with number 12? 185 degrees. Oh, good. Very good. Okay, good, Jack. Check mark. Done. All right, I'll kind of go in order here. 469, 51, 52, and 54. Sure, let's look at those. I've already forgotten 51, 52, 54. So for 51 here, they want sine, cos, and tan. They give you this relationship. You know the sine of 2 theta is 1/5. So the idea here is you are working with the sine of 2 theta, and 2 theta is greater than, it's in this quadrant here. So my original question, the sine of 2 theta is in this quadrant. And they tell you that in this quadrant, your opposite is 1, your hypotenuse is 5, and then they want you to solve for x. So in this case here, this is x squared plus 1 squared is 5 squared. You can go ahead and use Pythagorean theorem. You get 25 minus 1. X squared is 24. I get x as the root of 24, which that'll be what, 2 root 6, my x value. So that's your first step with 51. They give you this relationship. You know where 2 theta is bounded. Draw your triangle and like set it up like this. Now that I've done that, I want to find, for instance, I want to find the, if I want to find the cos of 2 theta, I know that, I know the cos of 2 theta is equal to, well, if I want to find sine or cos, it doesn't matter. I can use this formula here, and I can now because I know what the cos of 2 theta is going to equal, right? Because I know the cos of 2 theta is going to be my adjacent, which is 2 root 6, over my hypotenuse, which is 5. But I know that in that quadrant, it's going to be negative, so I have to tack on a minus sign, right? In this quadrant, your cos of 2 theta is negative. So I did my adjacent over hypotenuse and put the negative sign on. So I can sub that in here. This becomes negative 2 root 6 over 5 is 1 minus 2 sine squared theta. So then you can solve for sine of theta. This will be 2 sine squared theta equals 1 plus 2 root 6 over 5. Right, and there's the sine of theta. Right, but they told us in the question that your 2 theta is where it's bounded. So if I divide across by 2, that means that pi over 4, like theta is greater than or equal to pi over 4 and less than or equal to pi over 2. So that means I'm in this quadrant right here, which means that your sine of theta is positive. So I can drop the option of a minus sign, and you get that value. Okay, so there's sine of theta. I don't know who. I think Alexa, you had asked 51. There's the cos of theta, and if I wanted, or there's the sine of theta, I should say. If you want the cos of theta, then you'll have to do this again. Right, so if I wanted the cos of theta, I'll have to do this all over again here. I can do it again. Might as well do it because it's a question we've done. So if I want the cos of 2 theta, then I'm going to use this formula. Right, and I know the cos of 2 theta, it's the same numbers though. So it's going to be negative 2 root 6 over 5 is 2 cos squared theta minus 1. Let me just check that number. Yep. And then we solve for, I'll be solving for the cos of 2 theta, a cos of theta here. So this would be 1 minus 2 root 6 over 5 is 2 cos squared theta. 5 minus 2 root 6 over 5. And then we can take our cos square root. Again, you get plus or minus. So very similar, obviously, to the sine. Again, I'm in the positive quadrant. So because I'm in the positive quadrant, I can lose the minus sign. So because cos has to be positive as well. So I have the cos is equal to this one. So now I have my cos and my sine. Your tan you can find just by dividing these out. So your tan of theta is just going to be sine theta over cos theta. And six over 10. So these cancel. I end up getting the square root of 5 plus 2 root 6 over 5 minus 2 root 6. And that's the tan of theta. It'll be right here. Is this good so far? Whoever asked for 51. Okay, so there's 51. Let me see. I'll answer. I'm not sure if Alexa's still with us, so I'll take a look at. I was asking for 39 and 40 on 463. I can come back to them if Alexa's still there. 463, numbers 39 and 40. Yeah, 463, 39 and 40. Okay, so 463, 39. Oh, he's here. Okay, I can go through 52 and 54 later. Like after I do these two for IM. I can go through them if you want, not a big deal. Or if anyone else needs it, let me know. So I am with these ones here, what I would do is break this up off to the side of your page each one. So this is going to be cos x, cos of pi over 2, plus sine x, sine of pi over 2. And the cos of pi over 2 is 0. And I'll put down my sine x here. And the sine of pi over 2 is 1. So this whole thing simplifies to become the sine of x. And then likewise, you can do it with this one. So this is going to be cos x cos of pi over 2, which I did this already. Doofus. So this one we already did, which I did in class. I messed up too. So it's the same answer here. This is equal to sine of x. So I can get rid of this. This becomes sine x minus sine x cos x over negative sine x minus sine x tan of x. So they're not going to leave it like this. What they're going to do here is you've got that, I've got a sine x in the top, but you also have one here. This just becomes sine x over, oh, you know what? Let's just leave it like that. Never mind. I'm not going to factor it more. I'm going to actually just factor out the sine x. So in this one here, you can factor out a sine of x in the numerator, giving you 1 minus cos of x. Factor out, they would probably factor out a negative sine of x in the denominator, giving you 1 plus the tan of x. These will cancel. If you push that minus sign to the top, it becomes cos x minus 1 over 1 plus the tan of x. And that's your sort of your simplified expression for 39. So there's simplified for 39, and then the other one was 40. Okay, great. All right, so Tareem, did you still want, Emery wants 400 to 401, number 9E, sure. 401. Tareem, if Tareem's there still, I can do the other question. So I'll wait till Tareem responds just to make sure the sine of theta plus sine of theta is root 5/3. I'll wait for Tareem. Okay, Emery, you want page 400. Okay, 400 to 401. Number 9E. Okay, yeah, give me 1 second, Tareem. I'll help Emery and I'll do yours next. So 9E here. So Emery, for 9E, you are given the sine of x is 4/5. The sine of y is negative 12 over 13. You know that x is in the first quadrant, and you know that your y value is right here. And they want the tan of x plus y. So (9E). Wait, let's just go. So let's do our unit circle. So if I do my unit circle for the first one, like I said, I know I'm in my first quadrant. They told me I'm in my first quadrant. I know that the opposite is 4, hypotenuse is 5. So that's a 3, 4, 5 triangle again. So right away, I know the cos of x is going to equal, in this case, 3/5. And I know it's positive because it's positive in that quadrant. Likewise, I can do the same thing for my y angle. And this time I'm in the quadrant all the way down here. Right, this is the quadrant I'm in now. And now the measure there is going to be your opposite is 12. Your hypotenuse is 13. If I want my x value here, again, I'll have to go to quadratic equation, or I mean Pythagorean theorem. And then you can solve it. You get 13 squared minus 12 squared. X squared is 169 minus 144. X squared is 25. Excuse me, x is 5. So I got all this information here. I know that x is 5, so I know like the coordinates of my triangle. So using this, I now know the cos of y is equal to my adjacent over my hypotenuse, which is 13. Cos is positive in that quadrant, so we have that. So now, Emre, you'll notice I have my sine. I have both sines and both coses, which means I can divide them out. That shows up a bit better. I can divide these out to find my tan. So if I put this together here, I now know that tan of x is going to be 4/5 over 3/5, which is 4/3. And I know that tan of y is going to be negative 12 over 13 divided by 5 over 13 is negative 12 over 5. So now I have my tan of x, and now I have my tan of y. Right, so now I can answer the, I mean, this is a long question. They probably intended you to like use your answers from before. Like you could have just done sine of x plus y divided by cos of x plus y, but if you started this question from fresh, you'd have to do everything I'm doing here, right? And then just sub all this in to get your answer. This will be like 4/3 plus negative 12 over 5. 4/3. Are you following, Emery? So this ends up being what, 20 minus 36 over 15 divided by 1 plus 48 over 15. Uh, 63 over 15. Okay. It's a lot of math here. This ends up being negative 16 over 63 for the tan of x plus y is what I'm getting. Good so far? We're okay? I can move on to, I can take a look at Tareem's question. All right. Emery, I'll let you look at it, and then like you can look at it. I'll kind of write up Tareem's question here a bit, and then you can let me know if you need like any help with that. All right, so Tareem, for this question here, I believe they gave you the following information, and they wanted the cos of a minus b, I think. So what I was saying is if they're looking for this, the first thing you should do is go ahead and like write out your formula. Like, what is the cos of a minus b? Right, well, the cos of a minus b is cos a cos b plus sine a sine b. But I don't have that available to me. I don't have the cos of, like, the product of those values together. So what I was saying is when you get something like this, it's a common trig technique is to square both sides of the equations. So for both of these equations, I'm going to square both sides of them. So what I do when I square both sides of them, you're going to square the first. So you're going to get sine squared a. First times second times 2 is going to give you 2 sine a sine b. And then square the last is going to be sine squared b. That represents me squaring this. So if I take this and raise that to the power of 2, you're going to square the first. First times second times 2, square the last. And then lastly, I have to square the right-hand side, which is just going to kill the root and give you 5/3. Is that okay? That first sort of initial step? So then what I do is I do the exact same thing to the second equation. I go ahead and I square the first times second times 2, and square the last. Now I have this. So now I'm in a situation where I have these two equations I've created, but what's good about this is what I want is right here, and what I want is right here. I want both of those things together with an addition sign. This is literally my answer that they want me to find. They want me to find the sum of those two things I have highlighted in red. So I might as well just add them up. But the observation here is when I add these two up that I've highlighted in purple, those will add up to become a 1. And likewise, when I add up these two sides of the equation, what I've highlighted in orange, that'll also add to be a 1. Oh, it helps me solve the problem because of this point here. I've created this sine A sine B and sine cos A cos B. So now what I can do is I can take equation 1 and 2 and add them together. So by adding these equations, this adds up to become a 1. This just gets put back down, but that's what I want to find. So you can see here, this is just 1 plus 2 sine A sine B plus 2 cos A cos B plus, when I add these two, adds up to become a 1 using our identity, and this becomes 5/3 plus 1. Right, so I end up getting oh, okay. Okay, well, actually, Tareem, your way will work too. This way is a little quicker because I'm done now, but I can show it to your way as well. You could isolate and sub it in, and then it'll essentially the same thing will happen. So you could you could isolate for sine A sine B, isolate for cos A cos B, and sub it into this formula here, and you'll get the same answer. But now if I go to solve this, this becomes, like for mine, this becomes 2 sine A sine B plus, I can factor out that 2 cos A cos B. The 5/3 plus the 1 becomes 8/3 minus 2 So you can see here, this is right here, this is my formula. This is my cos of a minus b formula. So therefore I have 2 cos of a minus b is equal to 2/3, and then divide out by 2, you get your a minus b is 1/3, and that's your answer by adding them. Now, you can do it your way too, that you were suggesting. It's a little longer, but you can still do it your way. Like you can isolate for, like if you isolate for sine A sine B and cos A cos B, and you sub it into this equation, you'll get the same cancellation, the same algebra, and you'll end up getting 1/3 as well. Did you want me to do it your way too? It's up to you. I can do it your way as well. Sure. So, I assume we're good. I can use this information, and we'll go all the way down here. Let's do a new page. Here we go. Okay, and let's label this like alternative method. So if this is alternative method here, we'll do what Tareem was saying. So I'm going to isolate for 2 sine A sine B. So you get 5/3 minus sine squared A minus sine squared B. All right, that's me isolating. I'm gonna divide across by 2. It's the only problem. If I divide across by 2, we get 5/6 minus 1/2 sine squared A minus 1/2 sine squared B. The only issue is that you don't get that Pythagorean, the cos squared A plus sine squared A doesn't kick in till the very end, so you're kind of stuck with having the variables kind of kick around right to the very end. A cos of B. Okay, so that's me isolating like you were wanting to do. Right? But we know the cos of A minus B is cos A cos B plus sine A sine B, which is going to equal like this. Sick iPad skills, guys. Plus this. You guys, Tareem, are you following? So now I subbed everything in. So, what happens here? Minus 1/2 sine squared A minus 1/2 cos squared A. Those can be put together. And minus 1/2 sine squared B and minus 1/2 cos squared B can be put together. Right? Your identity works there. So this becomes 5 over 6 plus a half minus 1 half. So you kind of have to factor out that minus 1 half. So you can get that and then factor out the other minus 1 half. So you can get this. So you can probably see why I added both equations. But that's equal to 1 and that's equal to 1. So you get 5 over 6 plus a half minus a half minus a half is equal to 5 over 6 minus a half, which is 5 over 6 minus what? 3 over 6, which is 2 over 6, which is a third. You get the same thing. So that, like, it's a little more algebra intensive. Is that all right, Tareem? You probably don't like that version, I'd imagine. Okay, I'm going to leave this on the screen. Is there any other questions I can go through or things that people need to work on? Sure thing, Ali. 469.43 and Yusria, sure. So Yusria, with this one here, like, the idea here is, oh, the one I asked above. Okay, I got stuff to do here. Okay. All right, Yusria, with sure. Let me explain to Yusria the factoring. Abdullah, the 185 degrees, I don't see how you'd get like one of your unit circle values on that. Like, I don't know what strategy, like, where did you see that question? I'm not sure how, like, I don't see a multiple that it would hit as a nice one. So first of all, Yusria's question was, how did I factor? These two are the same. So I factor out the minus 1 half, and you get sine squared a plus cos squared a, which is 1. I did the same thing here. I factor out the minus a half, and then you get sine squared b plus cos squared b is 1. So they became 1. So you're just left with these values here, which all added up to be a third. That's how I got that one. Let me jot down Ali's question is page 469, number 43, and then Yusria's 501 numbers 1 to 4. Okay, just so I don't forget them. Abdul, I guess you can type in a little more explanation as to the 185, like what you're thinking. If you could type it up, like what you're thinking about, and then I can kind of work on that. I'll let Tareem take a look at the alternative method. Yeah, Tareem, the only thing I did here, it's a common trick that they do in math a lot, like a common technique. I mean, you sort of did it in your grade 10 with elimination, like adding equations together, right? We do that in elimination a lot of times. This time nothing was eliminated, but the idea here is when I add these two, generates a 1. When I add these two, it generates a 1. And this is what I wanted right here. So when I added those equations, I've got everything I want together, and then you add these two, you get your 5/3 plus 1. So by adding the equations, you now generate your like cos of a minus b formula. And then once I did that, it was just a matter of isolating for the cos of a minus b, which is kind of what we did with your solution. The algebra was a little cleaner. The only reason the algebra was cleaner is because you can do your Pythagorean theory, you can do your trig identity, both these equaling 1 right away. You got it? Oh, good, good, good. Okay, 185 degrees. Yeah, something like that, Abdullah. You'd have to have like some of your other formulas available to you that you could use, like, if you have some representation of sine 3 theta or cos of 5 theta, something like that. Um, that might help you, but the only way you could get an exact value is if you can land back to your unit circle numbers. Like you have to reference you have to have something that's known, like a number that's known on one side, so you could solve for the other. Um, like not every not every trig expression can be expressed. Or maybe I'm not sure off the top, but unless this has an answer, like if it has an answer, then I can think about it. But if it's random, the chances are it doesn't have an answer directly. But if it has an answer, we can think about it and solve it. All right, so 469, number 43. Let's take a look at that. This was Ali's question, 469, number 43. Oh, so they just want you to simplify this. So for this one, Ali, they give you 2 sine x cos cubed of x plus 2 sine cubed of x cos of x. So for this one here, number 43, they're asking you to simplify it. Like normally what we would do is we always look for a GCF. The GCF here is 2 sine x cos x. So right away, I'm going to factor out that 2 sine x cos x. I'm already thinking about the fact that this is equal to sine 2 of x. But what am I left with? I'm left with cos squared of x plus sine squared of x. And you know that this is equal to 1. So I'm left with 2 sine x cos x. And like I just said, Ali, that's equal to sine of 2x. And that would be the simplified question of 43. Is that okay, Ali? Did I do that too fast, or? Is this fine for 43? Sine 5 theta. You madman. Sure, if you want me to, we can do sine of 5 theta. I can find that. We can do that. Sure, I'll do 23 while I'm on that page, sure. All right, and then we got to get to Yusria's questions as well, 23. Oh, okay, yeah, that's a good question, Alexa. They got sine of theta is 0.3416. And they want the sine of 2 theta. To your trig formula, Yusria, 2 sine x cos x is sine 2x. That's what it's equal to. Alexa, for this one here, they want the excuse me, they want the sine of 2x, 2 theta. So I'm sure you wrote down 2 sine theta cos theta. Where you're having trouble is you're not sure how to find the cos of theta, but they tell you in this question that you're in the first quadrant. So I know I'm in my first quadrant here, and I know that your sine is going to be your opposite, which is 0.3416, divided by your hypotenuse, which is 1. Right? This this number here is 1 over 1. So therefore, if I want to find this x value, you just use your Pythagorean theorem. So I get x squared is 1 squared minus 0.3416 squared. So 1 minus 0.3416 squared. And the square root of the answer. I end up getting here x is 0.9398 approximately. That's my x value. So therefore, I know the cos of theta is adjacent, which is 9398 over hypotenuse. So that becomes my cos. So you can find your cos is the point. So now that I have my cos, I can just sub it in. 0.3416 times 0.9398, and I can get my values here. 3416 times 0.9398 times 2, 0.6421 approximately. Does that make sense for 23? Is that okay, Alexa? All right, I guess so. So there's 23. Okay, who's next here? I've lost track. Oh, Yusria wanted 501 1 to 4. For this one, they just want you to use your formula. Just this will be cos plus sine of pi sine of x. So this is going to be negative cos of x plus sine of pi is 0. Sine of x, so that goes away. Becomes negative cos of x. Right, so this becomes cos of pi minus x is negative cos of x. And it's the same sort of idea for the other ones. That's number 1. Number 2. Yeah, there's not much. You literally just, you don't have to simplify. You just write this out. This is all they're looking for number 2. Just to use your formulas. Right? Number 3. Number 3, that's just the sine of 35 degrees. Because that's the... Right? That's the sine of A minus B formula. For 3. So, So for 4 though, they do ask for the exact value, which we kind of talked about this already. They want the exact value of 105 degrees. Well, I broke it up into 60 plus 45, which we know each of those. So this is going to be cos 60, cos 45 minus sine of 60, sine of 45 degrees. So you can answer that because, oops. Like I know I can find those, right? If I want the cos of 60 degrees, or let's do the 45 degree angle. At 45 degrees, we know this is root 2 over 2, root 2 over 2. At 60 degrees, I know that this is going to be, just scroll in on this a bit. At 60 degrees, I know that this is going to be 1/2 and then root 3 over 2 for your values here. So when I sub this in, this is when theta is 60 degrees, and this is when theta is 45 degrees. So at 60 degrees, the cos is going to be 1/2. Cos 45 is root 2 over 2. The sine is going to be root 3 over 2, and the cos is root 2 over 2. So you can find your exact value here, to which we get root 2 minus root 6 over 4. Okay, so there's number 4 here. Is there anything else I can help you guys with? I'm not sure if I've covered, I don't know if I've missed a question. If there's anything else I can cover. 17 and 18. Sure. Okay, 469, number 25. Sure, I'll get to that too. Okay, so for 17 here, if you are looking at 17, they tell you tan of alpha is root 3, sine of beta is root 2 over 2. Alpha and beta are in the first quadrant. So I know alpha and beta are in my first quadrant here. And they want you to find the tan of alpha minus beta. So I need to find the tan of alpha minus beta. Sure, Michael. 53. Page 411, number 9. I need to find the tan of beta. So I have to go to my unit circle. I know that if I reference my beta measure, you're in your first quadrant, like they said. Your opposite is going to be, sine is going to be my opposite, so root 2 over my hypotenuse, which is 2. So I got to find this x value here, to which I get x squared plus Root 2 squared is 2 squared. So x squared plus 2 is 4. End up getting x is root 2. I guess, yeah, 1, 1, root 2, triangle, root 2, 2, 2. So this ends up being root 2 for your x value. So therefore, I know the cos of beta is going to be my adjacent over my hypotenuse, which is root 2 over 2. So therefore, putting that together, if I put these two ideas together, I know my tan of beta. Therefore, the tan of beta must equal 1, right? Because you just divide them out. So subbing this all in here, my tan of alpha is root 3, tan of beta is 1, and it becomes 1 times root 3 times 1. So I end up getting root 3 minus 1 over root 3 plus 1. And that ends up being my answer for the alpha minus beta, number 17. All right, so I'll take a look at, there's 17. And again, you can review it after I post this in the stream. It'll post all these questions. If you're looking at, like, for those of you who haven't done 17, here's a solution so you can check it out like later tonight if you need to. Number 18, it wants to find the tan of 2 alpha, cos 2 alpha, sine 2 alpha, where 2 theta, and the quadrant in which 2 theta lies, where cos of theta is negative 3/5, and theta is in the third quadrant. So in this question here, theta is in the third quadrant, so we're here. This is where theta is in. So this becomes adjacent hypotenuse. Quickly we see this is a 3, 4, 5 triangle. Again, this is a 3, 4, 5 triangle. Let me make this bigger. I'm not sure if the circles are big enough on your screen. Yeah, look. Oh, that's a rectangle. Okay, so if I draw this here, draw my angle, right angle, this is adjacent, this is hypotenuse, this is 4. So I know the cos of alpha, cos of theta is negative 3 over 5. They want sine, cos, and tan. So in this case here, I know the sine of theta is going to be my opposite over hypotenuse. In this quadrant, your sine of theta is negative, so I tack on a minus sign. So now I can go ahead and answer some of these here. They want the sine of 2 theta, cos of 2 theta. So if they want the sine of 2 theta, you just sub in the numbers above and you can get your answer. If they want the cos of 2 theta, once again, you can pick either one of the 3 formulas, sub your answer and get it. If you want the tan of 2 theta, just divide these out and you will also get your answer. So that's how you'd go about answering number 18. Okay, moving on here. If I look at 469, number 25, and then we can get to Michael's questions there. 469, number 25. Oops. All right, 469.25 is sine of 4 theta. Oh, I did 23. Okay, so Alexa, for this one here, the only thing you have to do is, since we did 23, it's going to be 2. You do your double angle formula on 4 theta. Looks like that. But we just found in 23 and 24, like you found the answer. This is number 23. And this is number 24. So you just sub your answers in for 23 and 24, and you get your answer for 25. That's how you do 469. And 50. 469, 53. Okay, so there's number 25. Michael, for 53 here, they want the tan of alpha over 2. So the way to approach 53 is I would actually divide across by 2 here. And if I divide across by 2, you end up bounding your theta over 2 between 3 pi over 4 and pi. So I divide it across by 2, and now I know that I'm greater than 3 pi over 4, and I'm less than pi. So you're in this quadrant here. Right, I'm in this quadrant, and I know that in this quadrant, my opposite is 1. I better write that in something else. My opposite is 1. My adjacent is 4. And if you go to this triangle, it's going to be 1 and 4. So I can solve for my hypotenuse. I end up getting h is the square root of 17. So I get h is the square root of 17 here. So the point of this is they told me the tan of theta over 2 is negative 1 over 4. So now I know that I can fill this out more. I know the sine of theta over 2, right? The sine of theta over 2 is going to be opposite over hypotenuse. So 1 over root 17. And in that quadrant, sine is positive. And then your cos of theta over 2 is your adjacent over your hypotenuse. And in this quadrant, cos is negative. So now they gave me this, and I've now found sine of theta over 2 and cos of theta over 2. Like you essentially just ignore the theta over 2, and you just find out what quadrant theta over 2 is in, which is what I did here. And then you solve for sine and cos. Now they want me in number 53 to find like your sine, cos, and tan. So the idea here is, you know, the sine of 2 theta in general is 2 sine theta cos theta. So if I let theta equal theta divided by 2, we kind of talked about this in class. You know the sine of theta is 2 sine theta over 2 cos of theta over 2. So therefore, the sine of theta, which is what I want, is 2 times 1 over root 17 times negative 4 over the root of 17, which is negative 8 over 17. I didn't do 24, Alexa. Oh, you guys can rewind. I didn't know that. Go back. But Michael, so I didn't do 24. I can take up 24 for you, Alexa, in a second. But let's get Michael's question answered here and see if it's okay. That becomes negative 8 over 17 for your sine theta. And likewise, if I want scroll down, scroll up. One guy wants me to scroll up, other scroll down. Scrolling up. I don't know. For Michael's question, to continue this question 53, if you wanted the cos of 2 theta, you know that's 2 cos squared theta minus 1. So therefore the cos of theta is 2 cos squared of theta over 2 minus 1. Oh, okay, good. I could have done it, but, you know. Negative 4 over the root of 17. Messy. Anyways, this is how you'd solve 50 whatever this is. This becomes 15 over 17 for your cos. So sine theta is negative 8 over 17 and cos theta is 15 over 17. And then obviously you can find the tan by dividing them. Okay, so I'm not sure, Mahir, if you got, like, if you can see if I'm in the right spot now with this, number 53 here. Scratch that. I do need 24. All right. Okay, I've heard nothing from Michael, so I'm not sure if he's still there, so I'll move on to Alex's question. 23 we did. I believe we got, where the heck is 23? Oh, we got 0.9398. 0.9398, okay. For 23. So for 23, we got 0.9398. Now they wanted, in 24, they asked for the cos of 2 theta. So if you wanted to answer 24, because you kind of need that to answer 25, let's just grab the information from 23. I'm just going to grab this here. Duplicate. Sick iPad skills, guys. Just beast mode iPad skills. So for 24, we solved 23. And we got this information here. It's all tiny, but there it is. And 24, they want the cos of 2 theta. So if I want the cos of 2 theta, I know that that's equal to 2 cos squared theta minus 1. So that's going to equal 2 times, I've got the cos of theta as 0.9398 squared minus 1. So therefore the cos of 2 theta here is going to be 0.9398 squared doubled and then subtracted by 1. I get 0.7664. So that's how you find the yeah, this is from the Algebra and Trig book, USRIA, page 469. Number 23, 24, and 25. So now I found the cos of 2 theta, and now you can you multiply those three things together, and you get your sine of 4 theta. It should be pretty close to the answer, 0.7664 times 0.9398, and then doubled. So 1.44, 1.441 for 25. Okay, this is good. 24, 25. All right, Michael, did you need, you got 53, but you had asked me 411, number 9. Did you still need that one? Oh, okay. Is that a question? All right, Mahir had asked this one. I can do it for you, sure. The sine of 5 theta. So if I asked you for 5 theta, you'd have to do 3 theta plus 2 theta, right? And then you'd have to use your formulas. This is sine of 3 theta, cos of 2 theta, plus sine of 2 theta, cos of 3 theta. Ah, slowpoke. I'll get back to it. I started Mahir's question here. Now this one, I don't know if I asked this one, but these tend to be a bit messy for 5 theta. Because you got your cos of 3 thetas in there, which we kind of did. I think I asked you for the sine of 3 theta. I guess, Mahir, or were you anticipating that, like, I don't think I asked this question. So are you guessing that maybe I would ask you the sine of 5 theta and then you wanted to see what that would be? Or did you want to see the solution? It's just a little computational. I can definitely do it. Yeah, you want this all in terms of sine theta. Oh, in terms of theta. Okay, is that in the homework? If they just want it in terms of theta, it's not as bad. Because I can take the sine of... You'd have to do this off to the side, like one at a time, but you could break this up a bit. Oh, sure. We can do it. So sine of 5 theta is sine 3 theta plus 2 theta. So you can break this up as sine 3 theta cos 2 theta plus sine 2 theta cos 3 theta. If they want it all in terms of theta, the only thing you got to do is get rid of these 3 thetas. So some of them are easier than others to get rid of. So for instance, like this is easy. This is easy. I can get rid of those right away. These ones are a little bit more work. So normally what happens is if this was a homework question, they might ask you like for the sine of 3 theta in a previous question, right? So in which case if they did ask that, you could break this up into sine of 2 theta plus theta. And this is sine of 2 theta cos of theta plus sine of theta cos of 2 theta. So I still got to get rid of these thetas. So this would be sine theta cos theta plus sine theta. And then this will be whatever one you feel like doing, but I'll do this one here. So again, the sine of 2 theta is 2 sine theta cos theta. That's the substitution I did. So I've got here, this is 2 sine theta cos squared theta plus sine theta minus 2 sine cubed of theta. So, I mean, we could simplify this more, but since the question you asked me was just like write this just in terms of theta, you know, it's a little easier. I don't have to like get rid of the cos or anything like that. There's my sine of 3 theta. So this, I can use this to get that part. Then if I want to do the cos of 3 theta, you could do the same thing here. I could write this as the cos of 2 theta plus theta. And this becomes the cos of 2 theta cos theta minus sine of 2 theta sine theta. And again, I can use any formula I like here of the 3 for cos of 2 theta cos theta. And again, doing that trick with the... Well, we only have one double angle formula to use. So I'll just use that one. And this ends up being what? Cos theta minus 2 sine squared theta cos theta. I end up getting here cos theta minus 4 sine squared theta cos theta. Right, so here I've got sine 3 theta formula, cos 3 theta formula. Then you sub it all in to this thing and you've got your final answer here. So this is, you could sub all this in and get your answer on this. If they just want it in terms of theta. I mean, we could do a little more work here to clean it up just to make the substitution a bit better. I could get rid of the cos squared theta and write it as 1 minus sine squared theta. I could kind of do that if you wanted to do more of it. So this becomes, you end up getting here 3 sine theta minus 4 sine cubed of theta, which we did in class and we talked about. So that's a little cleaner. This one here, I mean, we might as well do a little bit more work with it and just makes the substitution a bit easier. I can change that to your cos theta here. So that ends up being cos theta minus 4. This becomes minus 3 cos theta plus 4 cos cubed of theta. That's a little better, that one. So then you can sub all of this into this monstrosity thing here. And I end up getting what? 3 sine theta minus 4 sine cubed theta times 1 minus 2 sine squared theta. Yeah, you end up getting this here. It's not really that clean still. Still messy. Yeah, I mean, there's a little more we could do, but this is like essentially answered for that one. So there's sine of 5 theta. I don't think there's like a super clean version. You could Google it and see what the final result is, but a little bit more manipulation, we could get the final answer. So there's sine of 5 theta. Michael wants 411, number 9. All right. Oh. So for this one here, page 411, number 9, you have this x value. It's bounded in this quadrant. Like, you got to look at where are we in this quadrant. So if you take a look at unit circle, I'm in this quadrant here, which means this means cos is negative. So when I go to take my square root here, you get plus or minus the root of 10 over 11, but that's going to be equal to negative root 10 over root 11. Right, because the quadrant I'm in, after I take my square root, you get this minus sign on here. So now that I have the minus sign, I can fill up my triangle. I know where everything is at. This is going to be adjacent. My hypotenuse is root 11. To find this x value, we have x squared plus, like, sum of the squares of the legs of the triangle is your hypotenuse squared, in which case I get x squared plus 10 is 11. And you get x squared is 1. I get x is 1 here. So from here, it's actually not so bad. They want me to find the sine of x. That's going to be equal to your opposite, which is 1 over your hypotenuse, which is root 11. I'm below the x-axis, so you tack on minus sign with that one. And then you can go ahead and solve for cos of x, which, oh, they already gave us cos of x, did they not? Yeah, we know what cos of x is. 9, oh, that's 9a. 9b, 9b, this is a. For b, they want the sine of 2x. That's just 2 sine x cos x, which is 2. Your sine of x is negative 1 over the root of 11. And your cos of x is given to us as negative root 10 over the root of 11. So I end up getting here 2 root 10 over 11 for the sine of 2x. Oh, that was C. Sorry, B, B was, this is C. For B, we already know it. There's B. And then lastly, for D, they asked for cos of 2x. I'm sure you got it by now, Michael. If you're looking at for the cos of 2x, it's just going to be, you could pick any one of the formulas and sub it in. You can use this one, whatever one you like, and you can get your answer for 9D. All right, Yusria wants, good. 469, numbers 27, 51, 52, 54. I did 23, 24, 25. For 27 here, Yusria, let me see, where would 27 be? Where did I do these with Alexa here? Okay, I did 24, 25, 23, 24, 25. 27, we'll need all this information, so let me just kind of copy it. I'll duplicate it again. I'll bring this all down here as we go through all this here. Okay, here's a bunch of stuff. And they want you to find for 27, they want you to find the sine of theta over 2. To find the sine of theta over 2, what you can do is, like if I wanted to find that, I know that the cos of 2 theta is 1 minus 2 sine squared theta. So therefore the cos of theta is 1 minus 2 sine squared of theta over 2. So we already found out that the cos of theta, we found out the cos of theta was right here. My cos of theta we found out to be 0.9398. So I know 0.9398 is equal to 1 minus 2 sine squared of theta over 2. So then you just solve for this here. You end up getting here you get 1 minus 0.9398 divided by 2. I get the sine squared of theta over 2 is 0.0301. So I'm getting theta over 2 is 0.1735 for 27. This is Yeah, 0.1735. Okay, so that's how you go about answering 27. You just use the fact that the cos of 2 theta is equal to this. So then you just let theta equal theta over 2, and you can solve for your information here. That's a nice question. Okay, so there's 27. You 3 wanted 51, 52, 54. Okay, well, I did 52 already. I did 53. 51, I answered a bunch of times. They're all about the same, so. I'll pick 50, I don't know, 54 maybe? Let's take a look at 54. So for 54 here, they want you to find, they give you this, they want you to find the sine and cos like usual. So same thing as we did for 53, divide across by 2. And then you can do your unit circle. And in this quadrant here, I'm greater than pi over 2 and less than 3. So you're in this quadrant up here. So you've got your triangle. Opposite and adjacent is going to be this. So my hypotenuse here is going to be 3 squared plus 5 squared, which is 9 plus 25. So your h value is the root of 34. I end up getting this as the root of 34. So from here you can go ahead and solve for the sine of theta over 2. So you can go ahead and solve for the sine of theta over 2, which is opposite over my hypotenuse, which is root 34. And then lastly, the cos of theta over 2, which is adjacent over the root of 34, and that's a minus sign in front. So I end up getting here the tan of theta over 2 was given to us, and now I've got my sine and I've got my cos. So for 54, they want sine theta. I might as well answer this one while I've started it. But for this one here, we've got, they want sine theta. So you got the half angle again. You'll have to go ahead and like cos of theta is going to equal 2 cos squared theta over 2 minus 1, and then you can solve for the cos of theta. So I'll just do one of these and then we can wrap this up. This is minus 3 over root 34 squared minus 1. So I get 2 times 9 over 34 minus 1 is 9 over 17 minus 1. So 9 minus 17 over 17, and I end up getting negative 8 over 17 for 54. And you just kind of do the same for those of you who were asking with that one. Okay, and all right, you see what, 12, 15, 16. Number 12 is just the same thing we've been doing. It's, you would just do this and use your formula for number 12. Number 15 is the sine of 5 pi over 8, which there's a couple of ways you could do this one. If you wanted to, you know that the cos of 5 pi over 4 is equal to 1 minus 2 sine squared of 5 pi over 8. So you could do that and you could solve to answer that one, number 15. And number 16 is the cos of 5 pi over 8, so the exact same idea. If you want the cos of 5 pi over 8, you know that the cos of 5 pi over 4 is equal to 2 cos squared of 5 pi over 8 minus 1. Right, and that's just using, here I'm using the cos of 2 theta is 1 minus 2 sine squared theta formula. Here I'm using the cos of 2 theta is 2 cos squared theta minus 1 formula. So that's using both of those formulas there, just applying them to the top expression and solving. So that's how you tackle 12, 15, and, well, 15, 12 is pretty straightforward if you use this formula here and use your compound angle form for that one, and then 15 and 17. I think that's it. Okay, are there any other questions before we stop? We're getting around that 2-hour mark. I think I'm going to stop soon. Any other pressing questions before we are done? Okay, that's it. I'll go ahead and end the stream now. It should save if anyone wants to check anything out. It should all save for you guys. So that's it, and I will see you tomorrow.